Hey everybody, welcome back to another video. I know it's been a while, but today we're going to go ahead and go over 6.3, and your job will be to watch this video, take notes, and then work on the homework throughout the day, and obviously let me know if you have any questions. I will not be covering this in class the next time we see each other, and that is because we have a group quiz on Thursday, so that means on Tuesday we will be covering 6.4. So very important, watch this video, take notes, and ask me if you have any questions. All right, so let's go ahead and get started. 6.3, we are still constructing confidence intervals. However, the confidence intervals will not be for means anymore. Now the confidence intervals will be for population proportions. And this should sound familiar because this is actually how we started chapter 6 with the question about how many blue or orange beads are in the container I was showing, right? That was about proportions. So now we're back to that, and we're going to add some formulas, and this should be pretty easy now that you have a good idea of what we're doing. Just some new formulas. So really quick, what is the motivation? Why are we learning about confidence intervals? Why is this an important topic in statistics? Well, let's look at the following question. What percent of current students in the United States have been to summer school? Now, that's a pretty interesting question, right, to figure out. But how would you go about figuring that out? Confidently, at least. Well, I could make a guess, right, but that wouldn't be very confident. I could ask everybody in the United States, but that would be a lot of people to ask. So, as we do in statistics a lot, we take samples. But I want you to look at this question closely. What percent, right? That percent right there is another word for a proportion, right? Well, I spelled that wrong. Proportion. So by me asking what percent, that is what proportion, right? 30% is a proportion. 40% is a proportion. So I'm asking what proportion. And then also, current students in the United States, well, that is my population. So that is why I'm focusing on population proportions as shown in the title. Now with this, obviously the next question you might be asking yourself is, okay, we're going to take a sample, obviously, but how big does the sample need to be, right? There's a lot of students in the United States. So should my sample be 100 people, 1,000 people, 30,000, 100,000, right? How big of a sample do I need? And that is also going to be answered today. So it can be a lot of learning, and let's jump into this. So for starters, let's talk about population proportion. The probability of success in a single trial of a binomial experiment is P. Now, hopefully this word binomial sounds very familiar because we did have a test on this. But in case you're confused, let me refresh using the motivation example we had earlier. All right, so let's say we take a sample, and let's just say our sample was, I don't know, 1,000 students. Okay? Well, let's say out of those 1,000, 400 of them said yes to going to summer school, and 600 of them said no. And those are the only answers you can give, right? If I ask you, have you been to summer school? You can either say, yes, I have, or no, I haven't, right? You can't be in between. And if you remember, binomial experiment, the very first condition in Binns, right, was binary. Either success or failure, right? Success or failure. Well, in this case, because I'm asking, have you been to summer school? A success would be, yes, I have been to summer school. And a failure would be, no, I haven't been to summer school. So here I have 400 people that said yes. So that's 400 people that we can count as a success. and we have 600 people that said no, or 600 people that we can count as, a failure in this example. So that's why proportions are really binary, right? You either fit the proportion or you don't. You can't be in between. Therefore, we're using this language of binomial experiment, okay? So that will be P. All right, so let me draw a little picture just to kind of summarize everything. We're going to have a population, and using the same example still, right? And the proportion of students that have been to summer school is P. All right, and then we're going to take our sample, which will be much smaller than the population, and the proportion of students that have gone to summer school in this example will be P hat. All right, so for the population, it's P. For the sample, it's P hat. Now, more than likely, we will never actually know what the true population proportion is, because that would mean we asked everybody, right? And that's very hard to do. So we will use P hat to try to estimate P. Okay, and that's the idea here in this section of 6.3. All right, so what you need to know is P is for the population, P hat is for the sample. All right, now let's go ahead and quickly summarize what we've been doing and what we're going to do now. In 6.1, I had you build a confidence interval, and that was for means. So our hope was that mu was somewhere in there, right? And it didn't have to be. It could have been outside, right? Mu could have been outside the interval, but that was the hope. Now, 6.1 sigma was known, and therefore we could use z-scores and critical z-values. In 6.2, it was the same idea. We were still trying to estimate mu, right, by using the sample mean, and we were adding and subtracting the margin of error. But in 6.2, sigma was not known, and therefore we could not use z-scores. We had to use something called t-values and critical t. Now in 6.3, we're still going to be building confidence intervals, but it's going to be for proportions now, where, again, we hope the true population proportion, which is P, is somewhere in there. But again, it could be outside of it, but we're hoping it's in there. And hopefully you realize, yeah, we've done this already with the beginning of chapter 6. I just didn't give you guys any of the formulas for it, and now we will look into all the formulas. All right. So let's go ahead and talk about the first formula here. X will be considered the number of successes in a sample. Okay, so my earlier example, if you notice, I said there were 400 people that said yes, right? That would be my X. So that would be my X. Okay, and N is your sample size, right? So that won't change. So if you look at in this example, my sample size was 1,000, right? So that would be my N. So X was 400, N was 1,000. So then to calculate the point estimate for the population proportion of failures, that would be 1 minus P hat. Okay, why? Because P hat is the number, the proportion of successes. So for successes, you would do the number of successes, which is X, divided by the number or the size of your sample, which is N. So this will be your proportion of success. in the sample, okay? That's why we have p hat. It's in the sample. Again, X is the successes, right, that happened, and N is the sample size. Now, to calculate the proportion of failures, we would just do 1 minus p hat. Now, we're going to go ahead and denote that by using q hat. Okay? So p hat will be the proportion of successes, and q hat will be the proportion of failures. All right, so let's jump into our first example here. And this is example 1. In a survey of 1,550 U.S. adults, 1,054 of them said that they use the social media website Facebook. Find a point estimate for the population proportion of U.S. adults who use Facebook. So think about it. We have a really big population, right? And we want to find what proportion of them use Facebook. Well, there's a lot of U.S. adults. Our population is U.S. adults. There's millions of U.S. adults, right? So obviously we're not going to ask everybody. We're going to take a little sample. And our sample size here was 1,550. That's how big our sample was. Now, what is the proportion of U.S. adults that said, yes, I use Facebook? Well, it says right here that 1,054 of them said yes out of our sample size of 1,550. So the proportion of adults within the sample that use Facebook is about 0.68 or 68%, right? So 68% of adults in the sample use Facebook. Does that mean that the population is also 68%? Not necessarily, right? It could be higher, it could be lower. This is just from a sample, which is why we're going to use confidence intervals now, right? So we're going to have at the center our point estimate, right, which would be the 0.68. And we're going to go ahead and add and subtract our margin of error. Now, here is the formula for margin of error in this section. So please write this down. It is going to be the critical z-value multiplied by the square root of the probability of success, which is p hat, times the probability of failure, or the proportion of failures, which is q hat, divided by the sample size. Now, very important, this square root, when you use Desmos, the square root should be surrounding the numerator and the denominator, okay? It would be wrong if you just put it on the numerator like this. I've seen that before, so make sure when you type it, it's on both numerator and denominator. All right, so now let's actually try to build a confidence interval for this example. Let's go over some quick steps. The first step is to identify your sample size and the number of successes in that sample size. So this is your sample size, and this is the number of successes. And I'm going to put this in quotes because success just depends on, the problem that we're looking at, the context of it. Then once you do that, you're going to go ahead and find your point estimate, which is, again, the number of successes divided by the sample size. Now, there's always a condition you have to check, right? And then today, in this section, the condition is that n times the proportion of successes, when you multiply those two values together, it's greater than or equal to 5. You also have to check that n times the proportion of failures, when you multiply those together, is also greater than or equal to 5. Now, this seems kind of weird. Like, why are we doing this? The main reason is this ensures that the sampling distribution of p hat is normal. Remember, we always want to work with normal distributions. So these two things are very, very important that you check. Otherwise, you can't do any of this, okay? Now, after you make sure that those are true, you go ahead and find the critical value, which is the z-score, right? And then you find the margin of error, which is that formula we just talked about earlier. Then you're going to find the left and right endpoints. And again, how you do this is you're going to take your point estimate and subtract E, right? And then you're going to take your point estimate again and add E. So we've done this before. The only thing that changes is the point estimate. Then you're going to go ahead and form the confidence interval. So I'll leave it here for a second if you want to pause the video and write this down. But for the sake of time, we're going to go ahead and move on to this next example here. So we're using the same example as before. Use the data in example 1 to construct a 95% confidence interval for the population proportion of U.S. adults who use Facebook. So if you remember, we had our population, right? And then we had our sample. And the proportion of adults that used Facebook in our sample was 0.68. Right? That's how many in the sample, or that was the proportion of the people in the sample that said, yes, I use Facebook. Now, before I start jumping into using formulas, again, we have to check these conditions, all right? So I'm going to follow the steps, and hopefully it makes it easier for you. Step 1, identify n and x. So n is, if I go back, 1,550. So n is 1,550, and x would be the amount of successes, and there were 1,054 people that said that they do use Facebook, so that we will count those as successes. So step 1 done. Step 2, find the point estimate. Well, we already did that, right? Point estimate would be 1,054 divided by 1,550, and that is that 0.68. Next thing, verify n times p hat. So n times p hat is greater than or equal to 5, and n times q hat is also greater than or equal to 5. Well, remember, q hat is just 1 minus p hat. So q hat would be 1 minus 0.68, which means that q hat is 0.32. So let's go ahead and verify these things. N was 1,550. P hat was 0.68. And if I calculate that, that is 1,504, which is indeed greater or equal to 5. So that works. So this first condition, check. Check the next one. N is 1,550. Q hat is 0.32, and that is equal to 496, which again is greater than or equal to 5. So this also works. So check that condition. Now that I did that, I know that the sampling distribution is normal, which is good because now I can use z-scores. All right, so now that I have that out of the way, step 4 states find the critical value, right? And this has been a while. So the critical value that we're going to use is for a confidence level of 95. Well, luckily we already found the critical value for 95. We did this in 6.1. And the critical value is 1.96. We already found this value. Go back to 6.1 notes if you're confused on how I got this. And now that I have that critical value, I can go ahead and find the margin of error using this formula here. So let me go ahead and do that. I'll do it in a different color just so not everything's the same. The margin of error is equal to the critical value times the square root of p hat, which is 0.68, times q hat, which is 0.32, divided by sample size, which is 1,550. Now, this I can tell will be a decimal, so I'm going to round, and I'm going to get 0.023. Verifying decimals that you can get this value as well, okay? Follow along. Now that I have my point estimate and my margin of error, I can make my confidence interval, right? So I'm going to go ahead and put my point estimate at the center, which was 0.68, and I can add and subtract my margin of error. So I'm going to be adding and subtracting 0.023 and 0.023. And that's going to give me a confidence interval of 0.657 to 0.703. Again, pause the video at any point if you're confused and want to work this out for yourself. So what does this even mean, right? Here's my confidence interval. Cool. But what did I just figure out? Well, let's go back to our question, right? We wanted to figure out basically what proportion of US adults use Facebook. Now, I could ask every US adult, but again, that would take forever. So I took a sample and I calculated the proportion of US adults that use Facebook in that sample, which was 68%. But like I said earlier, this number will probably not be equal to that number, at least not exactly. It might be close. So we need to account for it by adding and subtracting a margin of error, which is what we calculated here, right? So what we can say now is that the proportion of adults, so the proportion of adults, US adults, right, that use Facebook is between like 65.7% and 70%. That's what we just figured out. Now let's go ahead and actually write this out. With 95% confidence, all right, so we're not 100% confident because this was a sample, but we're 95% confident. You can say that the population proportion of US adults who use Facebook is between 65.7% and 70.3%. That's pretty powerful. That's what statistics can do for us. And that's why we're interested in this these confidence intervals. So let's go to the next example here. The figure below is from a survey of 800 adults, US adults, from ages 18 to 29. Construct a 99% confidence interval for the population proportion of 18 to 29-year-olds who get their news on television. So obviously now, there's less and less people that actually watch television. So we're interested in, what is the proportion of adults from ages 18 to 29 that use television as their main source of news? Well, they already took a sample, right? This is the data from the sample. And the sample was of size 800. And everybody in this sample is between the ages of 18 to 29 years old. And again, we're only interested in the ones that get their news on television, right? So, which bar should I be looking at? I should be looking at the one that says television. So 27% of adults in the sample get their news on television. So that is the proportion of the sample. So then that is going to be my point estimate. Now let's go through the steps again, right? So find n and x, okay? So n would be 800. X is the number of adults that use television to get their source of news, right? So that would be 27% of 800. And if you calculate that really quickly, 27% of 800 is 216. Next step would be find the point estimate, which that was given to us, right? P hat is 216 divided by 800, which is that 0.27 or that 27% that was given to us. Next step, verify n times p hat and n times q hat are both greater than or equal to 5. So let's do that here. N times p hat would be 800 times 0.27. That is the 216 that we found earlier, and that is definitely greater than 5. N times q hat, which, what's q hat again? Q hat is 1 minus 0.27, so q hat is 0.73, so 0.73, and that is equal to 584, which is, again, is also greater than or equal to 5. So we can definitely go ahead and use z-scores now, because we know the distribution is normal. The next step would be find a critical value, all right? So our critical value here is for a confidence level of, what they say, 99%. So we want the critical value for 0.99, which again, go back to 6.1 to figure this out, but we should get 2.575. And now we are ready to calculate our margin of error. So we're going to go ahead and grab our critical value, multiply that by the square root of p hat times q hat divided by the sample size, and I'm going to round again. We're going to get 0.040. So now I can go ahead and build my confidence interval. So at the center will be my sample proportion, which, if I remember correctly, was 0.27. And I'm going to add and subtract my margin of error to that. And my margin of error I just got was 0.040. So I'm going to add and subtract that. And that means that my confidence interval written correctly would be 0.23 to 0.31. All right, so let's go ahead and answer the question now. With 99% confidence, you can say that the population proportion of 18 to 29-year-olds who get their news on television is between 23 to 31%. So that's for the population. I can be 99% confident that the proportion of U.S. adults that get their news on television from the ages of 18 to 29 is somewhere between 23% to 31%. So pretty low. All right. Now, earlier, if you remember, I asked you, how big should your sample size be, right? 1,000, 2,000. Well, there's actually a formula that we're going to use to calculate that. So given a confidence level and a margin of error, the minimum sample size, which is n, needed is given by this formula. So go ahead and pause the video, write this formula down. But this formula will give you the minimum sample size. If n is not a whole number, right, you use this formula and you don't get a whole number, go ahead and round up to the next whole number no matter what. Always round up. And if you do not know what p hat and q hat are, like they're not given to you and there's no way to figure it out, go ahead and assume that p hat and q hat are both equal to 0.5. All right. So with that being said, I want you to go ahead and try these last two examples on your own. Go ahead and pause the video. It should be pretty easy. You're just using this formula. And you can let me know when you're done in person. Shoot me an email and I can confirm your answer. But yeah, it should be pretty easy. All right. Good luck. Make sure you take these notes. And on Tuesday, we're going to go ahead and move on with 6.4.